I think it's safe to say we all know someone, whether it be ourselves or someone we care about, who's needed surgery. Therefore, we all know how stressful of an experience this can be for the patients and everyone who cares about them. In those moments, we all look to the surgeons and nurses to make sure the operation goes on without a hitch. But there's something about this process that many people often overlook or even take for granted, and that's the role of a hospital's sterile processing department.
Hi, allow me to introduce myself. My name is Alexander Shields, CEO of the Sterile Ferals. Along with my fellow chief officers Sean Patel, Tina Karimi, Haley Moore, and Curtis Hudson, we've come together to design and develop a novel device that will empower sterile processing departments around the world, known as the Genie.
As you can see here, sterile processing technicians currently protect our lives by decontaminating used tools with simple, handheld toothbrushes. For such a vital task, doesn't that seem a little odd? This method requires extreme attention to detail and patience. Rushing the step of the process can lead to inadequately decontaminated instruments. Subsequently, this can cause surgical delays, patient infection, or worse, patient death.
The challenge is then exacerbated due to the fact that these departments are constantly in a time crunch. The need for a high rate of tool turnover even causes some technicians to find ways to cut corners where they can, in an effort to save on time to meet the hospital's demands. Given all of these considerations and the unequivocal importance of these departments and their employees, the need we're hoping to address is that sterile processing technicians need a more effective and efficient method of decontaminating bioburden from surgical tools. That's where the magic and importance of a product such as the Genie comes in. Because the reality is, this is an inescapable problem affecting hospitals worldwide.
In examining the extent of our need, we first determined that there were roughly 164,000 hospitals in the world. Of these hospitals, about 6,000 of them are within the United States. And of this 6,000, our target population is 2,000 hospitals in the US. This number was determined from examining hospitals that have 100 beds or more because we know these hospitals are large enough to offer surgical procedures, thus they likely contain sterile processing departments with a larger volume of equipment being reprocessed daily. As mentioned earlier, the current tool used to decontaminate instruments is a simple toothbrush, specifically the one shown here. It is a nylon bristle brush that is double-sided to clean different surfaces and grooves, and costs about $6 per brush. We have received first-hand testimony from sterile processing technicians that their hands tire easily when having to use this brush for an 8-hour shift due to the vigorous effort required. It can be time-consuming because the bristle surface area is small, and it is hard to clean tough, stubborn spots on instruments because it is all manual powered. These were the shortcomings we aimed to address when developing the Genie.
This leads us to our solution, a pneumatically powered brush for effectively and efficiently decontaminating surgical instruments. With our solution, we are making the current process more effective, more efficient, and adding value to hospitals and patient care by reducing the risk of non-sterile instruments. As mentioned earlier, our device consists of a pneumatically powered design that begins with a compressed air line running to a foot pedal, which acts as an activator to release air into the tubes. Once the pedal is depressed, compressed air flows into the green outlet tube and exits the pressure regulator at a controlled PSI. The air hose is attached to the intake of the motor using a 1/4 NPT universal adapter. As air rushes into the pneumatic motor, it rotates an internal shaft inside the flexible gooseneck. This provides power to the handle that can secure any 1/4-inch quick connect attachments, or in this case, disposable brush heads. As the foot pedal is depressed, we can activate the rotation of the nylon brush head attachment and continue to decontaminate surgical instruments more effectively.
So how can we be sure Genie is a product that meets our stakeholders' needs? Our team began the process of needs finding in July of last year. Since then, we have spent over 30 hours in Duke's sterile processing department conducting ethnographic research and meeting with stakeholders to ensure we target the right need area. We went through an extensive solution landscaping process, presenting several ideas at board meetings and gathering opinions from our stakeholders on which solution addressed our need the best. We conducted extensive experimentation to test the feasibility and effectiveness of several different solutions for decontaminating surgical instruments, including air pressure, water pressure, electric toothbrushes, and finally, a pneumatically powered rotating brush. We were met with enthusiastic responses when presenting our ideas to Jennifer Vo, the Director of Sterile Processing at Duke Hospital, and also to Cliff Flintham and Rebecca McKenzie, the Vice Presidents of Perioperative Care at Duke Hospital. They provided us with valuable insight that allowed us to make Genie more marketable to hospitals and into the product it is today. Some of the most constructive feedback came from the Duke sterile processing technicians, the ones who actually scrub surgical instruments for hours on end every day. We set up an early iteration of Genie in Duke's sterile processing department to have technicians try out the product firsthand and to get their thoughts. The next slide will show you an SPD technician using Genie, then comparing it to the manual brushes they currently use to clean surgical instruments.
I mean, it's okay. It cleans a lot more faster than the manual brush.
Yeah, you're right. How would you do with the manual brush now that you have those three? Like, how would you show us?
Yeah, you have to. You start from here and go all the way up because you can't get everything like that.
Okay.
Covers everything. Once it spin from here, it spin all the way here and clean all this. So you'll have to go this way. And then when you finish, you turn it that way.
Gotcha.
And then you got to do it under the water too. So
you would like a bigger surface. Now going into our business model, our customers include the perioperative department, who is in charge of buying brushes. With the Genie, we are offering them a reduction in the risk of surgical site infection. Our second customers are the technicians, in which we offer an easier and faster way to clean surgical tools. And lastly, we have the patients, in which we are offering an ease of mind in that the tools being used for their surgery are fully decontaminated. We will be selling our brush heads through distribution channels like McKesson or Steris, and we will be selling our reusable pneumatic motor directly to hospitals. Our revenue stream will be in the form of a razor blade model, where the razor is the pneumatic motor set at a price of $550, and the razor blades are the disposable brush heads set at a price of $6. In comparing the current toothbrush to the Genie, you see in the table that both brushes can be used to decontaminate surgical tools. The Genie offers a reusable motor that is pneumatic powered in order to make the process of cleaning more automated, but as not to introduce electrical shock. It will also help reduce hand fatigue that technicians are feeling while using the manual toothbrush. Furthermore, we offer a higher throughput in cleaning, in which technicians can clean more instruments in a shift and subsequently decrease surgical delays caused by instruments not being ready. The brush head for the Genie also consists of a larger surface area in order to help technicians save time by giving them the ability to clean multiple instruments at once.
A 100-foot view of our project timeline reveals our completed needs finding in the end of 2019. We are currently in Q2 of 2020 with a finalized design and future verification and validation testing to perform. With a marketing team finalizing labeling and sales channels, our design will fully transfer to a manufacturing team, resulting in a product launch in Q2 of 2021. This timeline assumes no necessary biocompatibility testing, and our product is exempt from FDA submission. We are confident in our financial calculations, revealing a positive trend in business. At less than a 3% market penetration in year 3, we become profitable. This is possible because of our 470% product margins, with a product price point that is competitive with the current market. Our sales strategy will ultimately save hospitals money. They will recuperate the cost of the reusable base within the first 6 weeks. Long-term performance is even more favorable, with our total revenue surpassing our total debt breaking even in year 4. By 2028, with 7 years of sales, we anticipate a market penetration of 1/3 of the US, resulting in annual revenues of $40 million. Technicians are cleaning thousands of surgical instruments each shift, and hundreds of trays each day. The life-threatening cases hospitals are handling rely on SPD to effectively clean these necessary surgical tools. As surgeries throughout the hospital finish, case carts flood the bottom floor of the hospital. and the best equipment technicians have are toothbrushes. Give them the devices they need to clean surgical tools effectively. Wish away those contaminated tools, leave those manual brushes behind, and put technology into the foundation of hospitals. Once large hospitals are utilizing pneumatic-powered tools, it will be hard to imagine that they ever use manual brushes for decontamination. We appreciate your time and desire your feedback. If you have any questions or would like to learn more about our innovation or discuss how to invest, please contact the Duke Biomedical Engineering Department.